Good morning, students. Today we are starting our topic for studying about a new instrument. That is microtome. Have you ever heard about this instrument? Is it? Okay. Anyway, today we can go and learn about how it's work, what is the application. First point is the purpose of microtome. This is a picture of microtome. You can see this. What's the purpose? To cut uniformly thin sections for getting uniformly thin sections. Yeah, using microtome. If we make sections for observing under term, that should be of uniform size. If we done it manually, that size, that thickness will not be uniform. So, for getting a uniformly thin section, we are using microtome. And there are different types of microtomes. Which are they? Sludge microtome, rocking microtome, rotary microtome, ultra microtome, cryostats. All these are different types of microtomes. And all these microtomes we can categorize under two headings, two categories. That classification, that categorization is mainly based on whether that specimen stays stationary or it moving. On the basis of that, we are categorizing all the available type of microtomes. So, in the first category, the specimen remains stationary and the cutting knife is moving across it. And the microtomes, example for such type microtome, one example is sludge microtome. And in another category, specimen is moving across a stationary knife. An example of such type of microtomes are some name of some microtomes are given here. They are rocking microtome and rotary microtome. So we are going to see each type of microtomes. First is sludge. Sludge, as I told you now, sludge microtome. In that, the specimen remains stationary. The specimen remains stationary. This is a picture of a sludge microtome. First point, what is its purpose? To cut thin sections of wooden specimens, hard specimens. So, the sections that we can obtain out of this sludge microtomes are of thickness how much? 20 microns and above. From 20 microns onwards, we can easily get whatever section thickness less than this 20 microns. Understand? From 20 microns on thickness onwards, much less thick and specimens we can slice we can produce out of this sludge microtome. Okay, next slide. Which are its parts, how it works, that we are going to see in this point. And in this sludge microtome, a block of wood is there, and that wood actually we are going to slice. We are going to make thin section out of this block of wood, and it should be of 1 centimeter square cross section and 2 centimeter long. That is the optimal size for fitting inside this sludge microtome. And there is a clamp. Clamp means a holder to hold this wood is present in the sludge microtome. Then a razor. Razor means that cutting knife's name is called razor. Razor is actually here is a wedge shaped sharp knife for cutting this block of wood. Then a groove is present here, and over that groove this razor sharp knife is placed, and that level of the knife is adjustable. It is adjusting for what purpose? For obtaining a desired thickened slice section. So, by adjusting the level of the knife, we can we can produce sections of desired thickness. Okay, so in this video, we are going to see the working of a sludge microtome. Here, that wooden block is placing. Here we can see that wedge-shaped cutting knife, and that groove here. As this person takes off his hand from here, we can see that groove here, and over that groove, that cutting knife is moving across this wooden block for making thin sections. So you start to see this. In this way, that specimen is cut into thin sections. And that here a thin section we can see very clearly. Okay, that's about the sludge microtome. Enough. Next, rocking microtome. Rocking microtome also operates manually with the help of a person. It operates. So how it works? It works with the help of a moving handle forward and backward over a disc. That disc we can see here, and over this disc there is a moving a handle is there. By moving the handle over this disc, we can move the specimen. Here the knife is not moving, knife is stationary, and the specimen is actually moving across the knife to avail thin section. So we can just go and see this video how the rocking microtome works. Here the specimen is actually moving. This is an embedded specimen. Embedding we already learned that specimen is embedded in paraffin wax. In this way sectioning is going on. A thin film we can get
temperature of the wax.
Thinly cut specimen. Okay, enough.
That's a 6 micron.
Enough. This is the working of rocking microtome. Next, rotary microtome. Rotary microtome is the advanced version of microtome. Then how it works? It operated by a rotating wheel. That point need to give more stress. So it operated by a rotating wheel, and in addition to that, a rotating wheel is there, and a block holder is there. That block holder is actually moving up and down against a stationary knife. So here also the specimen is actually moving. Specimen is not keeping stationary in rotary microtome also. And a clamp is there. Clamp means a holder for holding the specimen in front of the moving head. And there's a wheel I already told you. It's a rotating wheel. Then actually this rotating wheel, its movement is in a vertical plane. Vertical plane means, I think you know. Vertical means in what direction? Okay, everybody know what is a vertical plane. That wheel's movement working in a vertical plane. But there is a feed screw is there. Feed screw means nothing. Yeah, that part actually moves the specimen forward to get the knife to move across it to get each section. Understand? Feed screw is actually that structure, that part helps to move the specimen forward to facilitate the knife to pass over it to make thin section. Understand? Okay. The feeding screws movement is horizontal plane and the wheel rotation in vertical plane. In the video, you will clearly understand about that movement. Okay. By that movement, thin sections is obtainable out of the specimen block. And in this also, knife is held by a hold. And the sections made out of this rotary microtome usually are of thickness ranging from 5 micron onwards. So next we can see the video of rotary microtome, how it works. So let's see that. Here is a tray for removing the dust and debris after the cutting procedure. This is the rotating wheel and the opposite side here. It's not visible in this position. As the video move to the other position, you will be able to see the feeding screw also. As it move here, actually we are fixing the block carrying the specimen. As we rotate this wheel, the feeding screw in this position moves, and as a result of that, this part here, a clamp holder is there, and in this holder we are actually placing the block carrying the specimen. By the rotation of the rotating wheel and the movement of feeding screw, this part moves much towards the front side, and knife is actually situated here. Okay, so as a result of rotation, this part moves towards here and get cut by the knife. So let's see that. And optic system also there. This way we can cut. Feed wheel. This is a feed wheel. By adjusting this measure, we can adjust the thickness of the sections. Knife is placing a protecting case in this red color. That knife's cutting angle also can be adjusted by using this lever. And our types. In this way, the specimen is fixing. Okay, that's about which one? Rotary microtome. Next, about the knives that is used in microtomes. Material of knives. Steel blades are sometimes used. It is mainly used for preparing sections of animal or plant tissues for light microscope. And also industrial grade diamond knives also used. That is used for hard materials like bones, teeth. And gem quality diamond knives, these are all very strong for making thin sections for electron microscope. So about the different types of knives. And there is another type of microtome, that is ultra microtome. Microtome is an automated machine. Automated means what? Fully automatic. An automated machine is for getting ultra thin sections for electron microscopy. In ultra microtome, the knife is of glass knives or diamond edged knives. Next. And in this ultra microtome, the sections that we made are usually fall in a trough with water, and this thin sections can if that sections are very thin, we can use it directly for the light microscopy also. Then peculiarities of ultra microtome is it is very sensitive. Sensitive means it's that section quality will be affected by any movement, also some vibration, change in temperature. All these factors will affect the performance of this microtome. So it is very sensitive, and it is provided with a binocular microscope also to monitor the sectioning process. To monitor the sectioning process, a binocular microscope also present. And for if that automatic system didn't function properly, there is another option for manual operation. A rotatable handle also present there. That's all the peculiarities about the ultra microtome. The next is about cryomicrotome. Cryomicrotome, what is peculiarity? It actually works for water-rich tissues. Water-rich tissues are first hardened by freezing. When it freeze enough, then it is cut and put in a liquid nitrogen chamber. This is a cryo. Cryo means some relating with the freezing. That you have to understand. So, what is doing here in cryomicrotome? They are mainly used in the case of water-rich tissues. Such tissues are first freezed and hardened, and after hardened, it is cut in a liquid nitrogen chamber. What is the advantage of cryomicrotome? It is faster, and as it is not treated with any chemical, there is less charge for the damage to the tissues, and it is suitable for immunohistochemistry. Immunohistochemistry means all the studies that involves reaction between antigen antibody. All such tests, this type of microtome is very useful. So laser microtome next. In laser microtome, main peculiarity is that there is no mechanical knife. Instead, a laser, a beam is used. A femtosecond laser means it's fastly moving beam. What is femtosecond laser? For understanding that, I have given a sentence here. The femtosecond laser is an infrared laser. Its wavelength is given here. It's a ultra short pulse duration, very fast beam, and that beam laser will cause only a minimal damage to the tissues. That is its benefit. It is contact free. It does not require any sample preparation techniques. All these are specularity. And the sections we can prepare out of this laser microtome is 10 to 100 micrometer. Okay. Next is applications. Applications also I have discussed along with the topic itself. Anyway, we are once more I am repeating. Cryo section actually helps quick diagnosis in medical field without altering the tissues. Ultra microtomes are mainly used to get thin sections for term purpose, transmission electron microscope. Sludge microtome helps to produce sections out of hard materials like wood, bone, etc. Laser microtome helps to slice every tissue in its native state itself without any alteration. In this way, we finish microtome topic and also today's section. Thank you.